If you use Decimator MDHX video converters like this one, then I have a much different and potentially more efficient way to power multiple Decimator MDHXs and make your setup way more streamlined. Because if you do use these, then you know how valuable they are for all of the HDMI to SDI and cross conversions and frame rate conversions that we need in video production, but you also know how messy your setup can get with, in my opinion, the overly large power supplies that these come with. So I'm going to show you another way to power multiple Decimator MDHXs at once so you don't have to use a ton of these larger power supplies, and that's by using USB power and replacing the overly large power supply with a USB to DC adapter cable and using a basic USB multi-output power station that can power anywhere from 2 to 10 devices at a time. So again, you can power multiple Decimator MDHXs from a single USB hub, kind of like this one, this 6-port USB-A charging station, and you can get USB to DC cables with either USB-A or USB-C ends on them and use a mix of both USB-A and USB-C converter cables. And here in just a sec, I'll show you this much larger setup and testing station where I have a lot of equipment being converted with Decimator's power this way. So this isn't obviously rocket science as long as you know the voltages and power draw requirements of your devices and you make sure your power source and cable isn't going to send too much voltage that could fry your equipment, then it's just a physical conversion of cables. And of course, always make sure that your DC cables have the proper polarity. In this case, most of the time, the center pin is positive while the outer shield is negative, but always verify the input polarity of your devices. But there are two things that make this fairly easy with Decimator MDHX products. Number one, the Decimator MDHX is interestingly very versatile in the range of voltages that it can accept in its DC power input. And number two, USB power is usually relatively smart in how it provides voltage. However, it can depend on the type of USB bricks and cables that you use, and I'll cover all that in just a sec. But I wanted to test this because my work is in live event production, and in those environments, or even in your studio environment, we have limited space and limited time to set up most of the time. And when we use lots of decimators, which is just about every show, it just gets very messy with cables running everywhere, lots of power strips on your tech table because you can usually only get a couple of these larger power supplies on a single power strip. And if you also want your decimators on a battery backup in case the main power goes out, then that's a problem because most battery backups only have one side of their outlets being powered by the battery. So it's a similar situation when using battery backups. And I just wanted to reduce the setup time and the mess of cables on live event productions. Now, real quick, remember that the Decimator MDHX is only powerable from its DC barrel input port. It does have a USB port, a mini USB-B port, but you cannot power the MDHX from that USB port. It's just for connection to a computer to use the Decimator software. However, the smaller Decimator MD-LX does already use USB for power with its micro USB-B port and the USB-A to micro USB-B cable it comes with. And other brands like Blackmagic microconverters are also powerable from their USB-C ports. All right, so let's go through this. How do we know that we can power a Decimator MDHX via a USB-C to DC cable with a USB power source? What do we need to watch out for? What might you lose? What size DC barrel do your cables need? And does it work? Well, I'll start at the end. Yes, it does work and it works very well. And you can see here, I'm able to power this Decimator with this small USB charging brick. And I've got a simple USB-A to DC converter cable. Now, granted, at the moment, this Decimator doesn't have any inputs or outputs connected to it, so it's not doing anything, it's not doing any converting, but I'll set that up in just a second. As far as the proper DC cable size, the Decimator MDHX's DC input needs a DC connector that has an outside diameter of 5.5 millimeters with an inside pin diameter of 2.5 millimeters. Now, some DC inputs and cables that go with them that have that 5.5 millimeter outer connector size actually have a smaller inner pin diameter of 2.1 millimeters, but the Decimator MDHX's internal pin is that larger 2.5 millimeters. And there are some DC barrel connectors out there that will accept both the smaller 2.1 millimeter inner pin as well as the larger 2.5 millimeter inner pin. So just make sure you get the right cable. Again, 5.5 millimeter outer diameter, 2.5 millimeter inner diameter. As far as what you may lose with this method is a bit of physical security on the DC power connector, because the original power supply and the Decimator itself both have threads on the connectors, so you can screw the power supply onto the Decimator and it won't come loose. And most of the USB-C to DC cables that I've found and bought do not have that threaded locking connector, so there is the risk of accidentally pulling the DC connector out of the Decimator. But not all equipment has locking connectors anyway, and smaller converters like the MD-LX that use USB power already don't have locking connectors either, so just be aware of that difference. Now, I did find some USB-C to DC cables that do have that threaded locking collar, so you can get that security back. But I didn't see a lot of USB-A to DC cables with that threaded locking collar, and the ones with the locking collars are a bit more expensive. This cable was 20 bucks, whereas these others were anywhere from $4 to $7 a cable, or sometimes they come in a 4 or 5 pack for about $15 to $20. So keep that in mind. A lot of these cables are cheap, and one of them that I bought didn't even work when it arrived. I had to send it back. So things to keep in mind when looking for quality or not quality cables. And I recommend having a multimeter handy so you can actually measure the voltage out of the ends of these DC barrels before you go plugging them into your very expensive Decimator. But I kind of like the option of being able to convert these over to USB power, because I'll show you how this can really clean up your setup here in a bit when we get off of this desk and over to my larger testing station. All right, so what I said before about the Decimator MDHX being versatile in its power is that right here on the front, the Decimator states that it can accept anywhere from 5 volts all the way up to 32 volts with its DC power supply. That's a huge range, which is great because it means as long as the DC connector fits and is the right polarity, it's going to be more difficult to accidentally fry a Decimator MDHX with too much voltage, because 32 volts is a lot for most small items like this, and for most of the other types of equipment you would find around Decimators, like portable video monitors, cameras, and small pieces of audio equipment. If they have a DC power supply, they're usually in the range of 12 to maybe 19 volts, and even the DC power supply on this Yamaha DM3D console is only 24 volts, and the Decimator's own original power supply is only 12 volts. And USB power, specifically USB-C power or power delivery USB-C ports, although those ports can provide up to around 48 volts, that higher voltage that you can get from USB-C power delivery ports usually requires a smart negotiation between the power supply and the device so that that particular USB power supply then sends the right voltage. But in this case, if you're using USB-A to DC cables, there's no smart negotiation anyway, because USB-A ports are only capable of sending 5 volts maximum. If you're using USB-C to DC cables, I found the results vary because, again, USB-C ports, if they're power delivery ports, can vary the voltage. I found that most of the USB-C to DC cables that I tried passed 12 volts, which again is fine for the Decimator MDHX. So there seems to be a bit of smart communication in some of the cables, but again, it's always best to verify with a multimeter, and I'll show you that in just a second. All right, so since the Decimator MDHX can run on a minimum of 5 volts, we'll actually test that real quick. I have an old iPhone charger. This is capable of 5 volts, 1 amp max. So 5 volts times 1 amp, that's 5 watts maximum that this will provide. So we'll plug it in, plug in my USB-A to DC cable. Now, first of all, I'm going to test the voltage on this before I go plugging it in. Put that there. And we see there we're getting our 5 volts out of the brick and out of this converter cable. So we'll plug this in. There we go. Now it's powered, and in a little bit I'll show you that this will actually still run and convert things on this 5 volt 1 amp brick. But other than just voltage, you really need to know how many amps, or really how many watts your device uses and needs to operate, because voltage alone won't get you there. And we need to make sure that our USB outlets on our charging bricks can provide, again, not only the required voltage, but that they can also provide enough amps and ultimately watts to power the Decimator MDHX. The unfortunate part is that the specs from Decimator do not list amps or watts in their spec sheet, at least not that I could find. So we don't know right away how many watts this thing needs to operate without shutting down or overheating the cable or wires. But we can easily measure the wattage being drawn, and we can do that by using the original power supply and putting this power meter between the cable I have coming from the wall, this power cable right here, and the Decimator, and we can measure and see right here how many watts this thing is drawing. So let me hook that up real quick. All right, so with everything plugged in, we see we're getting about 2.4 watts that this is drawing, but right now this isn't doing anything. It's just being powered. So does it draw any more amps or therefore watts if it's doing any converting? And I can show you that real quick. We're going to take my little Sony ZV-1 camera and we're going to convert that over to SDI through the decimator, and then we'll measure the wattage again. So let me hook this up. All right, so now we're converting the camera through the decimator over to SDI and my monitor here. And now we can see we're pulling a little bit more wattage. We're pulling 3.62 watts. So that's very little power, only 3.5, maybe 4 watts maximum that we're doing while converting one thing. I am scaling this as well. I'm scaling it from 23.98 frames per second from the camera over to, I think, 1080p 59.94, just to give the decimator a little something extra to do on this test. So knowing we're pulling a maximum of about 3.65 watts, I know that this little brick with its 5 watt max should be able to power the decimator just fine. So let's just hook this up real quick. All right, so there we go. Now we're powering the decimator with this 5 volt 1 amp brick. But the interesting thing is now our power meter is actually showing we're drawing more wattage. And I don't exactly know why it's drawing more wattage. It shouldn't be, but using this brick and this cable, it is. We're drawing 4.26 watts now. Again, this brick, 5 volts, 1 amps, maximum of 5 watts. We're almost at the maximum amount of wattage that this brick can provide. So I wouldn't recommend using a 5 volt, 1 amp brick. It will work in a pinch, but I would definitely recommend always using a USB-A port that is 5 volts and 2.4 amps, because that will just give you more overhead so that your devices don't get too hot. So we'll plug this in here, use this other brick. And now you can see with this other brick, we're pulling only 3.8 watts. Or I actually like using these multi-output ports so I can do lots of decimators at the same time. These ports are also 5 volt and up to 2.4 amps per port. So that's up to about 12 watts per port that this one can provide, which is more than double what the decimator is going to pull. So that just means these ports have overhead. And again, our cables and devices won't get too hot. And let's test some USB-C to DC cables. I've got one here. We'll grab our multimeter. And we can see we're getting 12 volts out of this cable, and this cable was advertised as being able to ask for and provide 12 volts, so I'm not surprised. Let's test another one. This is that USB-C cable with the DC locking connector. We'll test it real quick. This one also gives you 12 volts and may be more secure for your needs, since you do, again, get that locking connector for, again, just a little bit more added physical security. And one last cable. This one's interesting to where it has this selector switch in the middle to where you can set the cable to what voltage you want it to pull from your outlet. And as long as the USB-C outlet can provide that voltage, it will send that voltage through the cable. This charger only has options for 5, 9, and 12 volts. So here on the meter, we can see I can choose 5, 9, or 12. If this were able to provide the higher voltages, then I could select it on the cable, but we can verify all of this. We'll select 5, and we indeed get 5 volts. We'll change it to 9, and we get 9 volts. We'll change it to 12, and there we get 12 volts. So this cable may be better for you in some situations, so you can select that voltage and possibly protect your equipment downstream on that DC output. So this just gives you lots of options of powering your decimators via USB. You can use small bricks, you can use multiple output bricks that have USB-A and USB-C ports. Again, I kind of like this one that has these multiple USB-A outlets, mainly because it has a detachable IEC cable, so I can put this on the desk, run that single cable down to the floor, versus having to have a brick with the power prongs on it and then having to have another cable up on the table that I have to then connect and like secure that to the table. I just kind of like this option better. It's a little cleaner for my setups. All right, so that's a lot of info. Now let's go take a look at this setup where I have more decimators being powered this way and doing more things. All right, so here's my larger setup, and this is a lot of equipment, and you don't need to know exactly what's going on with all of it, but the point here is that instead of using all of the larger power supplies, I was able to clean up my power supply line here that I'll show you and overlay on top of this. And I'm using all of these USB to DC cables to power 3 decimators here. And I'm powering from that USB-A brick on the end, and each of those ports, each USB-A port is 5 volts and up to 2.4 amps per port. So that's 12 watts, 5 amps times 2.4 equals 12 watts that those ports can provide. And I wanted to power these up and run multiple things through them to see if they would pull any more than about that 3.8 watts that we measured earlier. And just let me summarize this whole setup. Initially, I didn't have an SDI source, like a camera with an SDI output, so I'm actually first converting my Sony a7 IV here to SDI with this Blackmagic microconverter. This is actually powered via USB from the same power brick. That is then going into the second decimator, and then number 2 here is outputting to this monitor and outputting 2 SDI outputs up to that monitor. That's a quad input monitor up there. Number 3 over here is taking the Sony ZV-1's HDMI and converting it to SDI. I've got 2 SDI outputs on that. But the big boy over here, what I really wanted to test was this one. This one is taking the laptop in, it's frame rate scaling it for the outputs. It's also taking an SDI in from, again, number 2 decimator, and I've got all 4 outputs hooked up. So it's not only cross converting with an SDI to HDMI and HDMI to SDI, but it's also frame rate scaling on the SDI outputs, and I have all 4 SDI outputs hooked up. We can see the output of this laptop here, twice there, and over there. So this one's doing the most, and now we need to measure how much wattage that's drawing. And for that, I've removed the DC to USB plug, and I've put the original power supply back in the decimator. And remember, this one's doing multiple things. It's converting the HDMI input, scaling it over to SDI, and it's also taking another SDI input and converting it to HDMI, and I'm using all 4 outputs. So this is doing the maximum of what it can do. And if we look at our wattage meter here that's plugged in, we're still only using a maximum of 4.65 watts. That's it. It's just 4.65 watts overall when this decimator is doing everything it possibly can. So let's swap back out to the USB to DC plug. Stand by. All right, so we'll plug that in, let it boot back up. And now this decimator is once again running on its USB to DC plug, doing all the same conversions, still only taking up about 5 watts maximum. So there is plenty of power available per port for an individual Decimator MDHX. So basically, that's it. This has been running for a long time. I see no issues thus far. Take it upon yourself to decide if you want to do this. Always be careful, measure your voltages before you go plugging things in. Always good to have a multimeter around. And I actually had access to a Decimator 12G Cross. This is the obviously larger 4K version that can take 4K in and out. And this one does take a little bit more wattage, but not much more. It only uses about 6.8, maybe 7 watts max. So it does actually work with the same USB outlets at that 2.4 amps. So the little smaller 5 volt 1 amp brick is not going to work for this. I'd be careful with that, but it will work with the same cables as long as you're giving it enough amps to where it can draw its necessary 7 watts or so. So anyway, that's it. I just really like this setup. Nice, a little more streamlined. I will leave some links to some of the things I use in this video. They are affiliate links. If you use those links, I do get a little bit of commission. Doesn't cost you anything, and if you want to use them, great. If you don't want to, no problem, but they're down there. And I think that's it. So I'll see you next time.